We have just finished Java basics. Now we are going to continue with working with Java data types. So in this section we will find primitive variables, identifiers, object reference variables, operators, wrapper classes. Primitive variables. First of all, we need to understand what is a data type. A data type is like a label that tells the program what kind of information a variable will hold. It helps the computer know what kind of operations you can do with that data and how much memory it needs. For example, integers are for whole numbers. Then we have floating point numbers, are numbers with decimals. Characters are letters or symbols. So you might be asking, why are they called primitive? When we say primitive in Java, we are talking about the most basic type of data that Java has already built in. These are simple types like numbers, characters, or true or false values. They are called primitive because they're the foundation of everything else. Then, in this section, we will explore the primitive data types in Java. These are the most basic types used to store simple values, and they come predefined in Java. Okay, these values are char, it holds a single character. Then we have byte, small integer, short, slightly bigger integer. Then we have int, a standard integer for whole numbers, long, larger integer for big numbers, float, single precision decimal numbers, double, more precise decimal number, Boolean, it holds true or false. Okay, I created this chart. So we have primitive data types. We have two families in there, numeric and Boolean. Then we have sign and unsigned. What is sign? This is a simple answer. Sign, it holds both negative and positive numbers. On the other hand, we have unsigned. Unsigned holds non-negative number, which means positive and zero. Let's come back to sign. Sign, we have integers and floating points. Integers, we have byte, short, int, and long. Okay, then we have floating points, float and double. Let's go back to unsigned, character and char. Okay, the Boolean family, Boolean, of course. Boolean data type is part of the primitive types in Java. It can only hold two positive values, true or false. We use that in a situation we have only two states, yes or no, on, off, true or false. Okay guys, let's continue with our code example. I have created this class called Boolean example. Inside that I created this main method. Okay, I'm gonna create two variables called voucher purchase true, and the other one we will call exam prep started, and we are going to assign it to true. Okay, this is going to be a very simple example. Going to if condition. Inside that we will place a voucher. If that condition is true, we will print. And we will print. You can register for the exam. If not, we are going to print. Please purchase a voucher to register. Okay, so we are going to print this. We know it's true. Voucher purchase true. So we will be able to see you can register for the exam. Let's see that in action. Okay, you can register for the exam. But what happens if I change this? Okay, I'm gonna make this false. Okay. Okay. Let's continue with sample. Now, if another if condition in that inside the exam prep, I'm going to print keep the preparation. If not, I'm going to print you should start preparing. You should start preparing for the exam. Okay, so we know that it's some prep stuff. It's true now. I'm going to print and we will see keep up the preparation. Okay, now what happened if I change this to false? We will see the other one. Okay, let's see this in action. You should start preparing for the exam. Okay guys, we just finished Boolean. Okay, now we are going to continue with numeric, specifically sign. Numeric. Integers are whole numbers, including positive and negative values. We use them decimals when points are needed. Java provides four types of that: byte, short, int, and long. Byte, 8 bits, range from this number to this number. Then we have short with 16 bits, range from this number to this number. Then int, 32 bits, long, 64 bits. Okay, why are there so many types in Java? The smaller types save memory and improve performance, but have smaller ranges. What are integer literals? Integer literals are fixed numeric values written directly in code. Java supports from different number systems to define integer values. Types of integer number system in Java we have decimal, base 10. This is the standard numeric system that we use every day from 0 to 9. Then we have binary, base 2. It uses only zeros and ones. This is commonly used in low-level programming. Then we have octal, base 8. Use number from 0 to 7. Historically used in computing. Okay, then we have hexadecimal, base 16. Uses from 0 to 9 and 8 to F. Often using memory address and colors. Why different number of system? Binary is essential for working with bits and hardware. Octal and hexadecimal offer compact ways to represent large binary values. Decimal is the default and most commonly used. This is some exam tip. The exam won't ask you to convert between number systems, but may ask you to identify valid literal integers in Java. There are some rules for using underscores in numeric literals. Underscores can be used to make large numbers more readable, okay, but they must follow some specific rules. These rules are: what you are allowed to do, you can place an underscore after the prefix 0 in octal values. Okay, later we are going to see some code examples for that. What you are not allowed to do, an underscore cannot be at the beginning of a number. An underscore cannot be at the beginning of a number. You cannot place an underscore immediately after this code 0b, 0b, lowercase or uppercase, okay, 0x. You cannot do that. You cannot place an underscore before the a suffix. You cannot do that. You cannot use an underscore with digits are respected. Okay? Tip: use underscore only to enhance readability, not to break up the numeric structure. Floating point numbers. Okay, now we have already finished with integers. Now we're going to continue with floating point. Floating point numbers are used to store decimal values. Unlike integers, they can represent fraction and are essential in situations that require precision. So whenever we require precision numbers, that's why we should use floating points. Okay, when do we use them? Here we have some examples. Orbital mechanics of a spacecraft. Yes, it requires high precision. The speed of Earth orbiting the sun. Yes. In Java, we can find two types of floating point numbers. These are float, 32 bits, less memory, lower precision. Then we have double, 64-bit, more memory, higher precision. Both float and double are used to store decimal numbers. We can use we can store decimal numbers in float and a double, but they differ in precision, memory usage, and range of values. Float, 32 bits, less precise and uses less memory. Since it uses only 32 bits, it has limited precision. Okay, limited precision. This is quite important to understand. This idea for saving memory when high precision isn't required. Then we have double, 64-bit. This is more precise, uses more memory, It provides high precision and it can store more accurate decimal values. This is preferred for scientific calculation, financial application, and large data sets. Some key takeaways you can understand. If you need less memory and can tolerate some precision loss, you can go for float. If you need high precision and accuracy, use double. By default, this is important to remember. By default, Java treats decimal number as double. So if you need an explicit float, you need to add f, maybe lowercase or uppercase, doesn't care. Okay, let's continue with our code example. I have already written some code in here, so we cannot. I can only explain that. Okay, so we have a byte shoved in long. Okay, byte minus 128. This is the minimum value for a byte. Then we have shoved 32,067. This is using underscore for readability. Remember that we can use an underscore for improve readability. Then we have in. This whole huge number. This is a minimum value for in. Then long. Remember that long, it requires an L. Then we have floating point values, pi. Okay, if we don't have the f, we will have an error. It could be lowercase or uppercase. Doesn't matter. Okay. Then we have a double. We add the underscore to improve readability. Okay, guys. So I'm going to print this. Okay. Here we have by. Okay, shoved in long float double. It's clear.